There are 16 different rare earth elements. These metals make up a $4 billion market that produces $4 trillion in associated products annually. Rare earth elements are involved in modern electronics, medical equipment, renewable energy technology, and electric cars. The Department of Energy has thus deemed it critical that the U.S. find sustainable sources of rare earth elements. Both coal and coal byproducts, fly ash, have been flagged for their high amounts of rare earth elements trapped inside of their aluminosilicate material. The coal fly ash has an exceptionally high concentration of the heavy rare earth elements, the most critical in supply as well as highest in price. The modern methods of ore mining for rare earth elements are quite inefficient. It requires deposits with acceptably high concentrations of rare earth elements, and even then, requires a massive volume of ore to be processed for a significant yield. Also, mining tends to cause environmental damage and sometimes political turmoil, so it's best avoided. For this study, batch experiments were conducted to examine the feasibility of extracting neodymium from an aqueous solution using an organosilica adsorbent, from here on known as Ozorb, and a ligand, the methane diphosphonic acid, here on known as Dipex. The concentrations of gram of Dipex versus gram of Ozorb were as the following: 4.45, 2.83, 1.11, 0.55, and 0.055 grams of Dipex to gram Ozorb. Figure 3 shows that the percentage of neodymium sorbed increases when the concentration of Dipex increases. Then figure 4, the next graph, shows that the absorption of neodymium when using only Ozorb was less than 10%. And then as acid molarity increases, the absorption percentage decreases, whether the Ozorb is present or not. When examining the 1 gram Dipex to 1 gram Ozorb ratio in a 300 part per million neodymium solution, around 40 milligrams of neodymium per gram of Ozorb was put into the media. However, as we added neodymium to the point of saturating the Ozorb, we found that the concentration of 1500 part per million of neodymium takes to the Ozorb of about 110 milligrams of neodymium per gram of Ozorb. So the next step for these experiments is to figure out an automated leaching process that will pump the aqueous Dipex solution at a certain flow rate through the Ozorb media and allow magsorption, then applying that to a large-scale industrial application.